Even three. One is the complete version. So if we get totally stuck, if I botch it, I can just refer to the complete version. So can you. Did you find them? Which folder did I stick them in?
Just under notes, and just get the last three on there.
Oh, well, it would help if I'm not looking at the online version of the class. Let's get the real version. Our version. Right. So what I'd like is there's one called fill in the blanks. And then there's copy stuff, which we're going to be putting into the fill in the blanks document. And then there's complete for emergency backup purposes, right? You can go and look there and see how I messed it up. Hoping I didn't mess it up. A couple of things we're going to do. We're going to write a server that you're going to be able to access through your browser. It's not going to do an awful lot, right? It's just going to service a request and then feed back a web page, which is just going to be a line of text. But we could expand upon that. And it will be educational to see what HTML kind of looks like and how it works behind the scenes. And that's one of the things that took the longest for me to do is I haven't done this one for previous classes. So it took a little bit of research. And I copied like a 20-line one, and it turned out not to work. And so I copied a 100-line one. It turned out not to work, so I just wrote it. And it turned out to work. I wrote it in two ways, a threaded version and an unthreaded version. So this is the unthreaded version just because it's easier. And then I can give you all the code to the threaded version if you want. So go ahead and open up Lecture Z copy stuff and Lecture Z fill in the blanks. Unless you're just not planning on copying and pasting anything, in which case, yeah, I would prefer you to open complete and just kind of follow along. But it's not going to have the tags like the other ones do, where it says A, and B, and C. So, fill in the blanks should be a text file. You could try to copy it here, but I would download it. It's just a text file, so you're going to have to, like I said, copy and paste. Probably change the name of the file because right now it's just called Lecture Z, and if you call it your project something else, not going to work. Okay, so I'm just going to highlight everything. When I downloaded it, did not? Okay. I'm going to open it in TextPad if you download it like that. Copy. Go to NetBeans. I'm going to make a Lecture Z project. Lecture Z. While you're at it, if you don't feel like messing with that project business and removing, the package business, you can always remove the package declaration from your main class right here and there, right here and now. Of course, it only takes 2 clicks to move it to the right folder anyways. So I did create main class, Lecture Z. Now I'm going to take everything out of Notepad. Control A highlights everything, or you can just do edit, select all. And then edit copy or right click copy. You know how to do this stuff. Highlight and paste. Now if I haven't botched it, all of this should already compile. It's not going to do anything, but it's going to compile. So we need to talk about what we see here. I stuck like 3 or 4 or 5 different classes all in this file, which is not, if I was smart, I would make us, put everything in its own file, each class in its own file. This seemed the easiest way to handle it though. I really kind of want Lecture Z's main way up at either the top or the bottom. And I didn't like the placement of this tags function that I made, but I just had to stick it somewhere in a hurry. But let's go ahead and look at a few points. No, we're not. We're not going to look at that yet. At one time, I had 2 different servers. So I implemented a abstract class, which was a server, and then inherited from it so that every server, had the same methods in it. I don't think that this one has that in it anymore. Could be. We'll find out. Scroll down to Lecture Z. Fix that name if you changed your file name to something else, right? If you did not call it Lecture Z exactly with all the caps or whatever, just make sure this matches your file name exactly. This function we're going to talk about in a bit, so skip. Keep scrolling down and you'll get to main. I think it'd be more awesome if main was sitting above all of that. So I might be tempted to copy the entirety of the main function and paste it. However, it's pretty long. Probably would be easier just to copy the tags function and put it down below main. But if you're not comfy copying and pasting and you think you're going to mess the braces up, just leave it alone. I'm going to go ahead and do that. I want this below main because we're not going to talk about it for a while.
I don't know anybody that messes braces.
No, that's pretty rare. Almost nobody messes. Okay, and where are you going to paste it if you copied it? I'm just inviting trouble. All right, right above the end class. And you may as well put another end method here. Okay. I'm doing that just to get it below main. I want main to be the very top thing in the file, pretty much. Except for there's another class way up there at the top. I'd even like to cut that and paste it, but we can find the Lecture Z file pretty easy. All right, so what's main do? It provides a menu. It asks for the choice. If the choice is one thing or another, if it's launch the browser or dump the HTML from the file, from the site we visit, then it asks for the address. Enter address, like HTTP rows, stuff like that. So that when we enter our switch, if they typed in a -1, it just quits. If they type in a -2, it's going to run our server. You know what, that looks like the whole thing, and I don't know why I have BBB there, but we'll take a look. Case 2 was a server that I decided to not inflict on us, which was a threaded server. Case 3 launches the browser. Case 4 doesn't launch a browser, but it opens a site and pulls out all the HTML from it. Then it sleeps for a minute just to give a second, just to give everything a chance to happen, right? Because otherwise it was printing out the menu a second time before we were done printing other stuff. And if our sleep gets interrupted because the client is dying, right? The client has been terminated, the program has been terminated, we don't care. So we catch the exception because it's mandatory, but we don't care. All right, so that's main. What are we going to do first? The funnest thing might be to implement the server. But let's go ahead and take a look at what happens if we try to launch the browser. Well, let's make sure that all of it works, that just by moving the method I didn't introduce any syntax errors, and that I have the class name correctly and the package and all that. So run the project. Alrighty. I'm going to launch the server. Doesn't do anything. Launch the server. Doesn't do anything. You can see that it's got that second sleep, sleeping for a second each time. Do number 3. Okay, it's actually asking for something. It's asking for an address. You don't have to, I'm going to go ahead and give it a good address. http://rose.edu. This is supposed to launch Chrome or IE or whatever your registered browser is. And it doesn't do anything, right? We haven't fixed that. And then 4. dump HTML. Again, http://rose.edu. Again, doesn't do anything, but we see the structure, right? It's just a little while loop. If we type in -1, it's going to quit. Even waits a second to quit. It didn't quit. Well, we certainly know how to quit things, but I thought that break was going to cause it to quit. I quit it like that, the old-fashioned way. Alrighty. So let's go back to main and find a good thing to start fixing. I want to be able to launch the browser. View a website inside the browser. So that's case 3. Case 3, what does it do? It hits a class called browser.launchBrowser. We can tell this is a static method because it's just attached to a class. We did not create a browser object and then call launchBrowser because this is a class method. Alright, we could scroll up and down looking for browser.launchBrowser. We could do a Control F and find launch browser. The most awesome thing to do is to right click, go navigate, declaration. That'll take us straight to that method, even if it was in another file. It'd be awesome if we cut the browser class out, stuck it in its own file. I think we can skip that unless you're just feeling it, right? Here's the whole class. It would not take us long to put it in its own file. If you feel like it, go ahead, right? Just highlight the entire class, go and add a new file to your project, copy and paste. Okay, here's a little print method. Why do I do that? Because I get real tired of typing system.out.println. If I put something like that in there, then I can just do hello, and it prints it, right? Just like I was playing with Python. Much faster to type that. Why did I put some dashes in front of it? Because parts of this are going to be multi-threaded. And I want to be able to distinguish the thing that one thread is printing as opposed to another one, right? We put all minuses in one thing and all pluses in front of another, and then when we're looking at the output, we can immediately visually distinguish. All right. So now that I have launch browser here and I added a print hello, if I run it again and tell it to launch the browser, I'm going to see it say hello, and I'm going to feel real good about myself after I type in an address. Hello. All right. I'm happy. It works. We know which function we are modifying now. All right. So what does this do? It launches the computer's registered browser. And it does so the same way that the second launch method that we implemented. By the way, Simon figured out what was going wrong. Is he had something in quotes that should not have been in quotes when we were invoking the launch method, launch Windows method. Now I don't remember the exact explanation. I'm not going to ask you to explain it. But
because we had the file name stored in a variable, and then we passed that variable into as a parameter for the method. But when I passed it in, I had fn in quotes.
Okay. Right. Okay. So let's go look. We're going to play Mad Libs here. Pick an adjective. Well, no, actually I'm going to go over here to Contents and find the fill-in-the-blank document. Or not the fill-in-the-blank document, but the copy stuff document. So Lecture Z, copy stuff. Again, we could copy straight from here, but it's much easier if we download it, in my opinion. Save it. Open it. I'm looking for D. Here we go. Just copy this top part. You could copy the whole thing because otherwise we'd have some more typing to do. Just copy that first try. Go back to your project and paste it. Immediately we get some errors because it wants some catches, right? So what is this doing? If we type in rose.edu, it creates a URI object. What is a URI object? Based on the address. Let's do a show Java doc on URI. I hope it works. Cannot perform show Java doc here. Oh, come on, it's been working every other day. Yay, all right, so I got it to work. What's the difference between doing it there and there? All right, so I just double click the first one, show Java doc. What is it? Implements a uniform resource identifier. There's more than one kind of uniform resource identifier. The HTTP address is one, but FTP : / is another one. Anything you can type up into the bar up here that has that / in it, it begins with the protocol, and it begins with the address. And after the address, there can be a port number specified. Like if I specify port 80, that's just a standard HTML port, the HTTP port, Hypertext Protocol port. I'm making special note of that because we're going to need it later. May have broken it. It says establishing connection. Whatever. So here we go. Creates an object from which we can do stuff. So there's the protocol and the scheme specific part, which is usually the address. So going back to our code, what do we do with that URI once we create it? Well, using the desktop.getDesktop, we launch browse. The day before, last week, we were using the desktop class in order to execute, Notepad and bring up our file in Notepad. We could split this into a creation and a launching. I'm not real fond of this kind of syntax where we chain these commands together. So if I was going to do that, you don't have to make this change because it already works. I would type in desktop, DT equals new desktop dot get desktop, and it's not popping up the little helpers, so I don't know what I'm doing wrong. In fact, it's complaining bitterly about it. Oh, nope, I don't even know. I'm going to underline. I'm going to delete it because it didn't work fast enough. Okay. So it returns the desktop object. What is the desktop object? It's a way that it interacts with the Windows desktop. If it's going to launch an application, great. If it's going to launch a browser, great. Anything that you can do. Well, I won't say anything that you can do with Windows. Send something to the printer.
Looking at our old lecture, it looks like you don't need the new keyboard.
Yeah, that would be correct. That would be correct. So, desktop DT equals desktop.getDesktop. Thank you. I was quite frustrated there. And then we can just call dt.browse. Why do I separate it like that? I just don't like chaining the commands like that. Creating an anonymous object is what it's called. Creating an anonymous object and then invoking, a method inside it. All right, now we do have we have some tries without catches. The reason we don't have any catches is because we don't have anything being thrown. So I'm going to add the catch clause. I'm going to add all the catch clauses. There's one of them. That was URI syntax exception, meaning it's a malformed address. And the next one is an I/O exception, failure to establish a communication with the desktop, or actually a failure to launch the browser. All right, I think we could come up with a shorter way of printing that we have an exception. We could leave that alone if you don't feel like replacing this logger with something else. But I think I added that cute little print function. Right? Browser launch browser exception. And then print, parentheses, quote, ex dot get, capital M message. Then I'm just going to delete my logger. And I forgot to put my parentheses in parentheses after get message. Now that's going to happen if we give it a malformed. As a matter of fact, why don't we just say browser, launch browser, exception. Well, let's just trust that get message has enough useful information. We'll test it by sending it a bad URL and figuring out how it catches it. In fact, I'm going to do that right now. I'm going to kill my program. I'm going to run it again. I'm going to say I want to do a browser, and I want to visit a site, and it generates the exception. Failed to open. Now I'm surprised I'm not seeing. Okay, there's my I'm not going to spend any more time on it, but browser, launch browser exception, I'm not seeing here. It's more like it jumped immediately to this one and ran it. You know what, I'm not going to mess with the exceptions anymore. We understand exceptions. I may just undo all of them and let the logger handles both of them. Alright. No, I'm not. Just get it to the point where it compiles. There. You can just copy that logger statement and paste it there. Save yourself some time from undoing it. Alright. And this is what the function does, the method does. So that little comment should have been up above everything rather than below it. I'm going to cut that comment and paste it up underneath the method name. And maybe I'll get rid of that annoying hello, or I'll give it something a little bit better, right? Like launching browser for end quote plus address. That should have been a plus. Close my browser. The reason I wanted to replace the logger with my own print statements is I wanted all those print statements to be preceded by my little special secret symbol that would have let me differentiate. Alright, so this is a browser, http://rose.edu. Is it annoying having to type http://? I mean //? We could fix that. And it launched the browser. It went to rose.edu. Did I show that last time? Did I show how, what could you do that for? You could create some help pages, right? Some HTML help pages that were as pretty as you needed to. And then if they needed some help, then instead of finding some way of generating, putting the help right into the application, you just launch the help page. You see that a lot anymore, right? Ask for help and it'll go out to Microsoft's website for further information or things like that. Alright, so I think we understand this, especially since we used the desktop object last time, and we get the idea now that we're creating an address from that. And run it again. Where'd my app go? I don't see my little.
It's still running, you gotta stop it.
Yeah, but I wanted to. Oh, it's down in output. I forgot. All right, so type in a bad URL and you just see. Okay, boom. It displays that, and then it should pop up the menu again after a second. All right, so that was a java.io exception. I got them in the wrong order when I was trying to change them right. Not going to fix it. However, tired of having to type HTTP, so I'm going to go back to my main. Fastest way is just to hit Control F main, or just scroll up to the top. And down here for case 3 or case 4, you don't have to make this change if you're happy typing in HTTP each time. Once we get the address, let's see if it contains HTTP, and if it does not, let's tack it on. Now this is slightly lame, because what if we want to launch an FTP client or something like that? Well, we're not doing that, so why not? If, parentheses, address dot contains, open parentheses, quote, HTTP, end quote, but we actually want to make sure it doesn't. So I'm going to add an exclamation mark before address contains, or I could have made it say if address contains equals false. Either one of those would be okay. Hit enter. We're going to add that. We're going to prepend it. Is that a term? Prepend. Address equals, quote, HTTP colon, and by the way, use forward slashes here just so that it doesn't, think it's an escape code, escape sequence. Backslashes are escape sequences. So forward slashes and backslashes work interchangeably. As a matter of fact, forward slashes are how you do it, right? If we looked at the browser, then we would see forward slashes in our URLs spaced out. It's file system on Windows that uses backslashes, but that's pretty unique. Okay, plus the address, right? Prepending the address to it. So when I run it, I can just type in rose.edu and be happy. All right, good. Save ourselves a little bit of time. What we ought to do, instead of looking for HTTP, because what if they did want FTP? Don't look for that, just look for the presence of the forward slashes, right? Because if they've specified the forward slashes, they've specified their protocol, and we don't need to put one in front of it. Okay. Invert the if. I always love these little offerings they give us, and they look so horrible after they do them. Undo that. Alrighty. Whoever is typing along, but your code is currently broken, let me come take a look at it and see if we can fix it. Are we all good, gang? Please to wave your hand if you want my eyeballs on your screen. No hand. Not even any fingers. Okay. Hope that part's clear enough. But we have other stuff we can do. What's this one? Dump HTML. Same idea. Go to the website, but we're not going to launch a browser. We ourselves want to establish our connection using Java. Not letting some external browser handle it. That's boring. Right? If we wanted to pull some data out of a web page, then we'd need something like this. So down here, I think we're done with this one. So I'm going to remove those little / BBB, but you could leave it there. No, we're not done with that one. We haven't done the server thread yet. I'm glad I didn't delete it. If you did, undo that. All right, but we have handled launch browser. That one's all good. Case 4 is not handled. Let's hope that it's in our fill-in-the-blank document, our copy stuff. I'm going to close this fill-in-the-blank notepad, so I only have one. Which one are we looking for? We're looking for CCC. Where are we? Yeah, we are. Because it's not even invoking it yet. We need to invoke that method. So, over here for CCC, this is just itchy-bitchy little code. That's not looking right. Yeah, it is. Sorry. Lost myself. Copy those 5 lines out. Looks like we're going to have 2 break statements in a row. Nope, there's no break statement for this, so that's okay. And paste it here. Now let's take a look at what this is doing. Now the browser class is something we wrote, not part of Java. So just like in the other one where we called browser.launchBrowser, we just added a print statement here calling browser.readURL to let us know what we're doing. And then we launch browser.url and then we print out the results. Well, what is the data? We'll find out what the data that's being returned is. It's probably just a string that contains the entire web page. Right now I'm not going to do anything. Let's run it and see what it does. Shouldn't return anything, so nothing should be printed, and tags should not do anything either. Let's run it. Choose dump HTML. Type in an address, rows.edu. Yeah, see, results is equal to empty. So what is this little series doing here? The browser.readURL returns the web page's text. And then it passes it to a method called tags. We'll talk about that method in a minute, but what it does is it tries to break it down by tags. It doesn't do a great job. Well, what's a tag? If you load up a web page, wish I could think of a simple web page. Old web page. So I'm just going to pick one at random. Alrighty. So, and then I do view page source. A tag is anything surrounded by angles. Every tag, or almost every tag, has a closing tag. So if I look at the bottom of it, there's a /HTML. If I look down at the bottom, there's a, well, not even there, not even at the bottom, right? So here's the header of the document. And then here's the body of the document. And down at the bottom is a /body. So you can see they're nested, right? And then there's a paragraph tag, which is a block of text. Here's an ahref tag, which is a link to another web page, a hypertext reference. You click on it and it's going to load up a different web page, just like this. You want to go to Yahoo? Well, if we looked at the very simple web page, there's a link to Yahoo somewhere. This isn't an HTML class. Just wanted you to get the idea of what tags are. There's a difference between tags and attributes. An attribute of an HTML tag is the word followed by an equal sign. This being simple HTML, there's not a lot of attributes in it, but if I look for an image tag, here's the image tag, and it's got something incredibly important, right? The picture that image is supposed to be. And then some alt text, which is supposed to be displayed if the figure fails to load, or if you're using a screen reader or something like that, you know, for the, you know, visually impaired or something like that. Okay. So what we want it to do is that first function, first message returns the entire body of the text as a string, and then the next one is supposed to take that string, split it into an array list where every member of the array list is a tag, right, like that. Now it's not perfect, and it's certainly not in a totally useful state yet, but it'll demonstrate it. Going back to our code, we need to get your read URL working. I'm going to double click on read URL, right click, navigate, go to source. All right. Now I should have made it where we copied and pasted, you know, even more, because I had to comment out these tries and catches. I was slightly annoyed that if you have some tries and you have a catch, but the catch is not thrown by the code, the compiler complains. No longer compiles it. It's complaining that it's trying. That's a little too smart for my taste.
Just trying to catch something that isn't going to run.
Right. If the compiler notices that the stuff between the try code does not throw that exception, then it will not let you have a catch statement to capture that exception. So that's why I commented everything out. Let's go back to our case document and grab code block EEE.
So we're uncommenting on it.
Yes, uncomment out all the trying to catch, or we could have just pasted it in and, you know, and then done the rigmarole we've done in the past where we add the exception handling ourselves. So uncomment everything from there to there, then grab block EEE. It's pretty short. Copy it, paste it.
Between the,
Pardon me?
you pasted it between the.
I pasted it exactly where the comment is,
Okay.
between the try. Exactly, good question. Paste it here, our little error should go away. So what is this doing? Ignoring the while loop for now. Don't space it out like that. It's building a URL rather than a URI. Now I'm not quite smart enough to know why we needed two separate classes to do that, but if I look at the Java doc for this, we see that a URL represents a uniform resource locator. How's that different from a URI? Not sure. Didn't read it carefully enough. But, right, it encapsulates this path. Just like when we created something that read a text file, it creates an object that can be passed to a scanner. So we can read from this HTML file, just like it was a text file, or just like it was a user entering text, right? Just a scanner instead of putting in system, .in. And again, we're doing the creation of an anonymous object there. Prof don't like that. I'm going to show Java doc on it. Find out what OpenStream returns. It returns an input stream. So we're going to make an input stream object that we can then pass to the scanner. Don't have to do this, it's already working, right? Input stream is equals URL dot OpenStream, parentheses in parentheses. And then inside the scanner constructor call, just pass in is. Now see, to me I like that better. A little bit more typing, but I like, because I might be curious about what an input stream is. And this way I could type in is dot and I could get a whole bunch of, methods. Now in this case it doesn't look like an awful lot. But it's got read. We can see that we did not have to create a scanner. We could be reading directly from the input stream. Byte by byte if we wanted to. Okay, but now that we have a scanner, we want to read from it like it's text. So I'm just putting it in a loop. While we has next, sounds like lolcats, right? Like in has cheeseburger, right?
There's actually a code that compiler that has syntax like that.
Oh yeah, that sounds cool. So, while we has next data, get that line out and print it. And oh, by the way, let's add it to a string so that we can return that string. You see, we declared an empty string up here. We're just tacking everything on. If all we wanted to do was to print our data out, we didn't need that. And again, it's calling our print function, so every line that we display on the screen is going to be preceded by the 4 hyphens. Then we have exception handlers. Looks like I already replaced the logger calls with print calls. And then we return the string that we built. Let's run it. All right, I want to dump the HTML. Enter the address, rose.edu. Now, if you view the, not that you can view the, here, let me show you what I'm about to say. If you type in rose.edu, it redirects itself to HTTPS. What is HTTPS? Secure HTTP, so that if somebody is monitoring your traffic, they can't see nearly as easily what you're looking at. Which is good, because it's now legal for your service provider to sell to whatever company wants to get your browsing history. If that doesn't alarm you, kind of oughta. Anyways, so it just immediately redirects. So the source code for http://rose.edu is very, very short. And then the source code for this is the real web page. So when we run our program and type in rose.edu, it's going to bring us a short version. Here it is. Now it's also calling that tags function, which I mentioned. I should have had us copy and paste that so we wouldn't see it immediately. But here it is. Enter the address, rose.edu, calling our browser function. Would have been nice if I put a space there. And here's all of our HTML that came in, which we didn't print it a second time. We didn't actually need to print it inside the function, inside the method, if we were going to print it when it came back. And it says, so, object moved, this document may be found at ahref. Now what I don't see is the redirect tag. So apparently something has changed a little bit so that it automatically gets redirected to the next one. But see, we're seeing our HTML. We're seeing the header, the title, and document. About the only thing we're not seeing is the body tag or the HTML tag. That's of interest to me. What about that simple web page we were looking at? If I can find it real easily and just copy and paste it, you don't need to do this, but here it is, a very simple web page. Yeah, if you'll type that URL in, I'm kidding. Just going to copy, run it again, dump the HTML for that. And we see it's much longer, right? But it's still, here it is. Starts with the HTML, starts with the header, ends the header, starts with the body. This is all the same stuff we saw when we right-clicked. Now something to note is that the browsers try really hard to be forgiving of errors. I would say that the fact that there's no HTML tag and that there's no body tag in that redirector page is a syntax error. But programming HTML is so complex that the browsers are designed to be incredibly forgiving. Like if you have a body tag but you don't close the body tag before /HTML at the bottom, it just assumes you want to do that, and so on. Same thing for like if you have a paragraph tag and you don't close it, as soon as it hits another paragraph tag, it goes ahead and auto closes it for you. Did we explain read URL carefully enough? Does this kind of make sense? Create an object based on the web address, open it as a stream, pass that to the scanner, and then just read it out. And if there was something we wanted to do with it, if we wanted to scroll and find $signs so we could pull some, prices out, like we do sometimes in our fundamentals class if we're following a certain book, we could do that, right? It's just pure data. We can do anything with whatever we want with it. Now this is the end of doing the browsing part, because the next two aspects are writing, well, I guess it's not the next two aspects since I didn't include the second browser, the threaded one. I mean the next server. We're going to do server next. We're going to write a web server. Yes, ma'am.
I need eyes. They can't find my tags thing. I moved it down to the bottom like you suggested.
Control F and the tags. If I can type it, I'll find it there. looks like it got moved into the server class. So when I said paste it at the bottom, it wound up going to the wrong class. I was not clear enough.
Okay.
We just need to cut it back out and move it back to the bottom of the lecture C class. Does that make sense? All right. Or we could call since it's a static method, we could stick it in any class we wanted. Put it at the end of the lecture C class. Oh, no, we're not done explaining it because I didn't explain the tags code. Anybody else? All right. But this one doesn't involve any copy and pasting because the tags method is already written. So find your tags method. Control F, tags. Fine, I found it here. Double click, right click, navigate, go to source. Here's my tags method. It's part of the lecture Z class, but since it's static, we could have stuck it in any class. All right, what's it doing? It's taking all of that HTML as a string. It's building an array, and then it's going to build an array list from it. We could have, I'm going to cut that array list function, that array list declaration, and move it underneath this split call. Why? Just because we create the array and then we split it, right? We don't need the array list by that point. The array list gets created down here. So what's split doing? Let me show you what split does using Python. So if I do this, string is equal to, and then I create a string, 1, 2, 3, 4, 5, and then I print string.split, and I want the string split by commas. That comma is the delimiter. And there, it created a, Python doesn't have arrays, but let's pretend it's an array. Right? It took the commas out of that string and it put each piece of data, each string that was separated by the commas, as a separate element of the array. So big deal. Well, what did we do? We did is every tag begins with one of those. So we split it based on that. Let's see what we got back from that. Let's make a little loop that'll print that out. You don't necessarily have to do this, and the reason I suggest that is, anyways. So, for parentheses, string s colon sar in parentheses, print parentheses s, and now, oh, we don't have a print function in this one? Okay, fine. System.out.println. And then I just really want us to, I'm going to put something in here just to visually distinguish it from everything else. I'm just going to put a \t in front of it, end quote plus, right? Just so that I can see the contents of this array when I run it. All right, let's dump the HTML. We're going to have to scroll up to see the results of the split call. rose.edu. All right, and if we look for the things that are tabbed over, this is the results of the split. Well, where'd our open angles go? Somebody tell me what happened to our open angles. Why are we not seeing them in our array? Yeah, they're part of this. They were removed by the split, right? If you have a comma delimited list, then after you split it, you don't want every data element to begin with a comment. Excuse me, a comma. So one of the things that the code does, I decided to do, is to go ahead and reinsert that opening brace. And that's what this little bit of code down here does. And at the same time, we're adding the opening brace. We're adding it to an array list so that we can, print it out as an array list, or you could do whatever processing you wanted to based on the array list. So it's a for loop. I'm not real clear on why I made it an index-based for loop. It could have been a for each loop. At one time, it needed to be an index-based for loop. We could change this to a for each loop real easily. Why don't we do that? I'm just going to delete all this. Inside the for string s::sal, nope, sar for our string array. Now the only problem is that we have this line, but we don't need this line anymore. We can delete that line because that's handled by the for each loop. All right, so what's this do? It removes white space from the beginning and the end of the string. HTML doesn't care about spaces, but if the document has spaces in it, it'll send it to us. And what do I mean by it ignores spaces? If I'm looking at the HTML for something, whatever, and then I find a print tag or anything like that, a paragraph tag, it doesn't matter. Why can't I find a print tag? Control F. Control P. All right. It doesn't matter whether there's a single space there or a million spaces there or a whole bunch of tabs and carriage returns. When it gets displayed on the screen, it's just displayed as a single space. So I just wanted to remove all the spaces in tabs and carriage returns at the beginning and end of each one. So that's what trim does. Then we check, is this a real tag? It ought to be. I think that since we split it, everything with an open angle is going to have, but if there's no close angle on it, then we don't want to add an open angle. We're just making sure. If there's a closed brace, then prepend an open brace. And oh, by the way, if it was empty, well, why would it be empty? And if you have something like that, then when you split it, you could wind up with emptiness. That seemed to be the case when I was looking at it. So if it's not empty, then we add it, we append it to our array list. So we're building the array list that we could then return. Apparently, though, I just return the array rather than the array list. Either way. And then lastly, what do? We display every tag we found. Now here's what I mean by it's not perfect. But I'm not even sure what perfect would mean in this case. Let's run it again, or at least let's go back to the output tag and look at what it showed us. Here's all the tags. The problem is it's not keeping track of what is an open and what is a closing tag, because you can nest tags, and so it kind of loses some of the structure. But we could certainly look for things. For example, we could find all the image tags, and then if there's no image in it, we could bail. We could not print it out. So if I wanted to filter out everything that didn't have an image in it, I could add an if statement here. I don't necessarily advocate you do this, but you could, and then delete it, right? So if s: contains, parentheses, quote, img, end quote, or, you know, even angle IMG, end quote. Then print out that tag. But I have to go to a website that has pictures for that to work. Let's find a website with pictures. That, yeah, yahoo.com has a lot of pictures. Let's see how many of them we can find this way. I'm going to kill my app. I'm going to rerun it. I want to dump the HTML, but this time the final product is just going to be a list of the image tags. You could get to it just by typing in www.yahoo.com if you didn't have it stored in memory. No, if you do that, you better put HTTPS in front of it. https://www.yahoo.com. And is it telling me that there's only one image tag in this? That seems unlikely. You can see that Yahoo has an extraordinarily complex web page. We could validate that just by going to Yahoo, right-clicking on it, view page source. Oh boy, it's long. Alrighty. Find an image tag. Well, there's one. Okay, there was more than one, so I'm not sure why we're not seeing it in our little browser code here. I'm not going to spend much time working on it. But you know me, I get obsessive. I'll try not to be. What if I just look for the word IMG? Or we could look for the P tags, the paragraph tags, and print out only the lines of text. Dump the HTML. In our address, https:// you know what, I bet the Rose webpage has images on it. Why don't I just go there? https://rose.edu. And I think I saw a bad URL. Because I use backslashes and it's supposed to be forward slashes. Alrighty. https:// What did I do wrong? www.rose.edu. Alright, and there it is. And here's all of our images. That's what I was expecting to see. What would be nifty slick is if, like, we copied all those images into a file and we could display them all, or we could save them to disk, or right, that would take considerably more effort. But right, we get paths to images. I kind of bet that if I copied this into the URL up here, https://yahoo.yahoo, and then went into the media directory and tried to pull out building.png, I expect it'll display the picture. Now, it could be wrong. Maybe it's setting its home directory, just, you know, home directory, its root directory, because we saw that it's referencing something and we don't know what. So I thought that that was going to be directly off the yahoo.com. Not working. That's okay. Not working. If it had a fully qualified path to an image, it would work. There's like the world's oldest web page that I've ever found behind, except for the ones that are at CERN, where the World Wide Web was kind of invented. If I go to...
Professor, it's because, didn't you go to rose.edu to get the image? What is that?
Derp, you're right. Thank you. My faith in the universe is restored. Rose.edu. Media 102 building. Thank you. And there's our building icon. Brownie points. Okay, there you go. Right, so that's working. we're getting a list of images out of it. We could trim them so that it was in a better format. I don't see why we need to do that, right? But we could look for an open quote and then trim it of the closed quote or whatever, right? And then we're seeing all sorts of noisy stuff here. But we could conceivably pull out all of the images and just provide us with a straight list of images. How are we doing on time? Gee, we have 20 minutes to talk about the server. I talked too long about this. Let's go look at the server. That has to be the output tag. What are we looking at here? What? All right, still there. Don't know what I was saying wrong. Oh, it is the output tab. I hope I didn't just lose everything. All right, now it's back. Okay, so the last one was choice 1, launch server 1. So if I do Control F case 1, all right, it's all gone. Well, //BBB, let's go take a look at what's there. And to me, it looks like it's already there, but I can go and look here. Oh, something we don't have to copy. It's already there. That's all right. So what's it doing? We played with threading a little bit, but it creates a thread object. Well, a runnable object, which is different than a thread. A runnable object is something that you pass to a thread. You build a thread. The thread's a wrapper for your runnable object. And then we call tu1.start to launch our runnable object. So let's go find our server thread object, class. Right click, Java, navigate, go to source. All right, and so server thread implements runnable. Had to. Which, since it's an interface, okay, since it's an interface, requires our run method to be implemented. Do not make the changes I'm making at this moment because I'm going to fix them. Right. Since it's a runnable, the interface says it has to have a run method. Otherwise, the thread has nothing to run. So let me undo those changes, and let's go and look at our copy document. Find section AAA. And boy howdy, it's long. No, this is looking wrong. Not sure what I'm seeing here. Oh, this is the tags function. It should not be in the copy stuff document. It's all right. Here's everything that needs to be inside that method. Now, through my playing, I wound up making a run which called run1, which is stupid, right? We don't need to do that, so just copy these 4 lines out of the run1 method and paste them into the run method that we see here. Copy, paste. All right. And it's referencing something called print. That was a helper class I had when I was trying to make everything, easy to run. Let's add a print method so that we can, no, just change these in a hurry. System.out.println. We only have to fix 2 of them, right? System.out.println. All right. So what's it really doing? It calls sr.run. What is sr.run? Well, that's our server object. The thread is just kind of a wrapper for the server object. What does it do? It's going to open port 8080. Now I mentioned ports one time. https://, well, it looks like it wants to load up Facebook. I'd rather not do that. www.rose.edu:80. Well, that's the HTML port. However, this server is going to run on port 8080. Not sure why, but every code example I've seen does that. That must just be some kind of convention. But we could change it so that it would run on the HTTP port. It would be listening on that port. Let's go look at the server1 object. Class. Navigate, go to source. Here's our server1 class. It extends the server superclass. All the server superclasses is something that has a port number and an abstract method that it had to fill in. Like I said, at one time I had several different server, running or implemented. This would no longer need to do that. We could have made it a non-inherited solution. But anyways, it's going to take the port, and then it's going to use the port, and oh, by the way, it has another print method, which is going to precede everything it prints with asterisks. And it's got a build message. We're going to look at build message a little bit more closely in a minute, but all it does is create our HTML. We can see it right here, right? HTML head, title, example, paragraph tag. Amazing, it worked. Create a date. All right. And that's going to be called by the run method. The run method's got 2 blocks of text. Since there's no space between them, it obviously could have just been one. And it's got a try and a catch stuff just that we have to uncomment just like we did the other time. So let's do that. Uncomment all the try stuff. Uncomment all the catch stuff. It's complaining because nothing throws IO exception. Well, it will as soon as we copy the guts of FFF and GGG in there. So find FFF and GGG. Well, there's FFF. It's incredibly long. Oh, and there is no GGG, so this is everything we need. So from FFF all the way down to the end. That looks like way too much. Get it down to the line, the brace that's before end try. Another way to say that is that in your copy document, you could take end try and delete everything down to the end before you copy it. I'm suspecting that brace errors are going to occur real soon. Anyways, that's what we need. Everything from FFF down to the line before the end try. That closing brace before the end try. And it can just replace both of those. One time I was playing with splitting them up, decided not to. So what's that one? If you're curious where the open tag that matches a close tag is, you can put your cursor on the close tag and hit Control Open or Control Curly Brace, and it toggles between the two. You see what's going on? All right. So here we go. Try all this stuff. Well, what is this stuff? Create a server socket. The way an HTML server works, or the way any of this stuff works, is if you're communicating by sockets, which is the internet protocol that supports all this, then there's got to be something that's listening to the outside world. Pretend that this is a fancy ear, right? And your Windows computer is going to be, or your browser is going to be talking that way. That's the server socket. This is what the outside world communicates with. And then inside, in order to do stuff and send data to the ear and back out, then there's going to be internal sockets. This one stays open the whole time, waiting for connections. And then inside, the program interacts with that, reading from it, sending data, and then it closes it, and then this thing is still waiting for a new connection to come in. Now, ideally, this is written as a multi-threaded thing so that it can handle a lot of requests coming in at the same time. Because you may get a new request before this thread is done servicing the old one. So that's our server socket. He's listening to the outside world, listening for a connection on port. It's set to go to 8080. While true. Well, we're about to accept. Now accept actually sits there and waits. It blocks until it gets a connection request from a client. Once we get our connection request, we get the input stream from it. And we've seen that input stream before, right? We could just put a scanner around it. If I'd taken the time, I would have changed this buffered reader to a scanner just because it looks a little bit more familiar to us. But it's the same thing, it's just a reader. And now keep getting data from the client until the request is done. Here's what we're reading from the client. While the read line is not empty, or does not return null, I really particularly do not like embedding function calls inside my inside my requested and comparing them like that, but that's okay. And then if the line is empty, break it, else print the line out. So this is the stuff we're getting from the client. Every HTTP request, every request that the server gets has information from the client, which we will see in a minute, like a GET request. A client can send a whole bunch of kind of requests, but GET just means return something from you. You know, yo, I want some information. But the client sends some information, like what kind of protocols I support, you know, what IP address directed me here. We'll see a whole bunch of information that Chrome sends as part of its GET request, and it'll all be printed out here. I wish I'd taken the time to write this as a scanner because it'd look a little bit more familiar, but it's the same idea, right? While, has next, then call get line, print it out. If we had a little bit more time, we'd make that change. We should actually do something with the information contained in the data because, like I said, there's more than GET requests. The server may be trying to post something to the client may be trying to send data to the server, right? They filled in a form. They clicked a button that said send. Well, that's not a GET. It's going to interact with the server. It's sending data back, so it's not a GET. But all we're going to do is a GET. So like I said, we should do something with the information out of the request. This is all the information that came with the request. All instead we're going to do is send a page back. So now we need to make an output socket, right? We made an input socket, we got some data from it, and now we need to make an output socket which is going to go back out to the requesting client. And then we're going to build a message. And then we're going to send that message using os.write. We're going to write that down to the output string. And here's what we wrote, by the way, right? We got a string here, but let's display it as well, just because we like seeing stuff. So we print that message. Remember all that header and HTML and stuff like that that the build message function up here created? This, by the way, took me a considerable amount of time to debug. Right here when we were building the message, one of the things you send is a content length tag. And if that's wrong, if you send the wrong content length down, then the client may not behave as well as I would have hoped. Okay, so what do? We send whatever text we got, our header tag and body tag and whatever, down the socket with the write, and it gets delivered, hopefully, to the client. But the server's job is done by the time it sent that request back. So it just needs to flush the socket, needs to close the socket. Right? As soon as we send that information back to this, it's very transactional. Yo, give me some data. Server does something, it sends it back, it closes its internal socket. Then we say, do another one. Yo, I'm going to put some data back to you. Well, it opens the sockets, It does stuff and then it closes those internal sockets. The outer one always remains waiting. And then we have a catch. All right, if I haven't added any brace errors or anything of the like, when I run it, I'm going to create a server running on my machine listening to port 8080. So I'm going to run server 1. Closing everything to make sure I don't have anything goofy going on. All right. Run server 1. Running the server, listening for connection on port 8080. About to accept. So it's blocked, it's waiting. But that's why it's created as a thread, right? It's running inside a thread because it's waiting for a connection. But our program could still go and do something else. We could, browse to rose.edu or something, or heaven forbid, we could even browse to our own server that we're running. So that's why that was implemented as a thread. That's why our server class is embedded inside the threads run method. It's waiting for a connection. Why don't we do it? Let's ask ourselves. Now there's something called a loopback address. If you type in 127.0.0.1, that's yourself. Now it's annoying to have to type that. So instead there's also an alias called localhost. So if you type in localhost, it tries to access a web server running on your own machine. But we need port 8080. So localhost : 8080. And apparently I still have this running on Python. That's crazy.
Still there.
I don't see it running. It must be cached. Okay. If you get the Vince will be the only one who gets that. If you get that Beatles webpage, that was from our Python version of this. And then you rerun it. This is being generated by our Java program. I showed you that it made some HTML that said amazing it worked, and then it tacked the date onto it so that we could watch it get refreshed every time. If I do view page source, I'm going to see exactly what my server is generating. Let's go look at the output of what our requests are looking like here. Right? That's messy. I'm going to close it and try to access it just once. Although for some reason, on my office computer, it was issuing 2 GET requests every time I tried to load it. Don't know why. Run it again. Start my server. It's listening. Go to localhost 8080. Amazing, it worked. Go back, look at my output, see what I got. So I just scroll up to the top. From the client, this is all the text we got from the client. And the client said, yo, I want to get some information.
Where do you key the local host? I keyed it in my run, but it's not, and then it had ended, so it's not evidently know which.
Right here, inside this Chrome. So get everything running again. Get your application running again. Look, break it and run it again. I don't trust it. Okay. Did you kill it first?
I did, I didn't stop there.
All right, then run the server with 1. It's waiting now. So load up Chrome. In your browser, just erase everything and type localhost : 8080. Hit enter. There's our web page. We have written our own web server. We can go into business. Web servers are extraordinarily complex things nowadays. But back in 1992 or whatever, they were pretty simple. They only had to handle GET requests and POST requests. Let's take a look at the data that we got. We got a GET. We said that it's telling us the host. It's got some information, keep alive. Insecure requests, I don't know what this, and this is all the agent information. In other words, the client is configured to send this to every web page it sends. It's saying, oh, by the way, if you send me a zipped document, I can unzip it. I'd like for you to send me text, HTML. or XML. My user agent, these have gotten weird over time, but you can see that Chrome says that it's Mozilla, which is a really old browser, and that it's also built on the Apple WebKit format. And you go, why is Chrome using Apple WebKit? Well, just because they are. And it's telling us its information. And it's telling us this. This information here, all of this information here is used to fingerprint you whenever you're surfing the net so that they can try to track you even if you have cookies turned off. I think that they can ask for more information than just what you see here to try to further, narrow you down.
Is that like what's in cookies?
Kind of like. The web page can request information from cookies, and then it would come in as part of the of this request. And then here's what we sent back to the client. We sent back HTTP, that's the protocol, 200 OK. That's telling the server, okay, your request succeeded and I'm about to send you some data. What am I sending you? I'm sending you some text, some HTML, and the body of it's going to be 119, and you better not get that wrong. And here it is. Here's our body. We could go and customize our body if we wanted to. I think that'd be fun because we're about done. Fortunately, I don't think anybody follows us. We could hang out an extra 2 hours. We got other things to do. So go back to your code and let's change the message that's displayed. Find the get message, the build message. Just do a Control F and look for the word body or amazing or something like that. So instead of amazing at work, it's going to say Java server is up and running and is so awesome. And let's make that a different color. So, as part of the P tag, we can specify some style information. So before that P that says Java server is up and running, angle P before the close, style equal, so this is an attribute, quote, color, colon, red, semicolon, end quote. Now I made a goof. The goof is that since our string is declared with double quotes, we can't embed double quotes in this, but fortunately HTML allows you to use double quotes or single quotes. So wherever I typed in a double quote, we better replace that to a single quote so it doesn't mark it as the end of the string. Kill my server, run it again, choose server 1, go to Chrome, listen to local, I should just be able to do a refresh actually, and it says Java server is up and running and is so awesome. Last thing I'd like to do is find that 8080 and change it to just port 80, which is the standard HTML request. No, I'm not going to do that. But is anybody broken at this point? We've broken your code. Because I'm interested, we have this stuff, right? We can choose other things. We could launch a browser. So just scroll down here and type in 3 in your little output window. Enter our address. Localhost colon 8080, and it launched Chrome, opened our window. All right, now the tension mounts. Are we going to be able to dump the tags? 4, localhost colon 8080. Now here's all of the information that we got back from our own server.
Cool.
Looking like something's gone on. Oh, that's because I printed out the array, right, just to demonstrate that the opening angles were missing. Anyways, so here's our results. Those are all the tags. That doesn't look like the tags. That's okay. You get the idea.
Why? Yeah.
By the way, try to launch your server again, even while it's running. Type a 1 and try to launch it again. That makes me think that.
It's already
Try to
in
launch
use.
server.
Oh, we just launched this one.
Right, right. Okay. Yeah, if you choose a 1 a second time, just, the server's already running, that port is busy. So it can't do anything. Right, server is already in use. Now where did that happen? If we go and look at our code and search for the word bound, we don't find it. What, did I remove that? All right, I don't see what's being generated. It's the point where this is being created.
Bind, I think.
You found bind?
JVM_bind, it's in the message.
Oh, right. It should have been right here. Instead of generating an exception, we could put a is bound call there to check to make sure whether the bind was successful. And if it wasn't successful, then, we print a graceful error message rather than letting the exception be generated. That's okay. That's what exception handling is for, right? To make programming easier. May not always seem like it, but if you've done programming before, you may be used to sticking a whole bunch of print debug statements, and if this return call failed, then do something, and the exception handling is supposed to make that easier so that the errors can be passed back to the code. Now we've been handling all of our exceptions like this, but we could do this instead. We could remove our catches, and this is the very last thing I say, by the way. We could remove our catches, and then when we get an error based on that, boy, there's a bunch of errors, then we could add a throw clause, and it's not there. Dadgummit. Okay, anyways, and then the throw clause would pass that back up to the calling method, and the calling method would have to invoke the, unless that function had a throws clause, and it could pass that exception all the way back up to main, so that these individual methods do not need to go to the trouble of handling all these exceptions, right? So they can just toss the exception and then main does stuff with it. All right. Was that interesting? I hope that was interesting. I hope it was worth not having your brains ready.
Make us a Dropbox.
I will make a Dropbox.
Good class professional.
Thank you.